We were talking about displacement. Now, let's contrast that with total distance. Again, we have ourselves a position function, and its velocity is, of course, the derivative of that position function. And its speed, all I got to do is take the absolute value of the velocity function. And it's this function that we have to integrate in order to find the total distance. You're basically integrating the speed function over some sort of time interval. So in this particular case, this capital V is some sort of antiderivative of your speed equation. And it's not usually written as a particular function that you can get very easily because you do have an absolute value function. We've seen absolute value functions before when you have to find the antiderivative of, you have to break it up at its vertex so that you can switch the position of the positive part, or the negative part, I should say, and make it positive. Okay, so this is going to give us the total distance traveled by that object over the time interval from t1 to t2. The absolute value basically is going to take that negative velocity, and make it positive. So here, let's take a look at a graph of this thing, a nice little graphic. So displacement, as we talked about before, that will be positive. This will be negative. It takes that some of that distance away and then adds in this positive distance that's up here. Okay, but as far as the total distance goes, it's going to take this negative part that's up here, it's going to reflect it up to the top, and then you're just adding all of those distances together. Of course, that's what the absolute value is going to do for us. So let's take a look at that on example 10. A particle moves along a line so that its velocity at time t is v of t is equal to some very straightforward parabola here, measured in meters per second. Find the distance traveled. When it says that, find the distance traveled, the implication is total distance. If they want displacement, they will use that word. So find the distance traveled during the time period from 0 to 4 seconds. Okay, all right. So understand that our first step, of course, is to set this thing up. And our total distance is going to be the definite integral over the time interval that they give us from 1 to 4 of our absolute value of the velocity function, our speed function. So the absolute value of t squared minus t minus 6 with respect to time. Okay, so again, finding an antiderivative of an absolute value function is not something that we do. We usually break it up into pieces. Let's draw a little graph here of what this could look like. So I need some axes. We are going from 1 to 4 here. And let's see, if I were going to graph this thing, set it equals 0, let's just find some intercepts here. And I would factor it as a t and a t. Let's see, a minus 3, a positive 2, which means that you have t equals positive 3 and a negative 2 as far as the x-intercepts go, or t-intercepts go. Let me move this over a little bit. 1, 2, 1, 2, 3. Right. All right. And it is a positive looking parabola. So we have a one here, and then of course it would hit that y-axis at negative 6. So here's probably approximately what our graph would look like. All right, it doesn't have to be perfect, just something to look at. And we are going from, let's say, 1 to 4. So this part that's down here at 1 needs to be reflected up. So all of this stuff is going to be reflected up. So really, our graph is going to look like this. So it's going to start from up here and then come down like that. And we're essentially finding this area. And then we're going to 4. So plus another little part here. If I had left it like this and just found some negative part down here, it's going to cancel out with this positive part up here, and that would have just given me displacement. But I need total distance, so I have to take this negative distance that it traveled, so basically distance that it traveled either downwards or to the left, and make it positive, so everything adds together. So we can tell, of course, that the equation of the right part is just the original equation, which is v of t. Okay, but the red part over here, it's the opposite of that because I just reflected over the x-axis. It's negative v of t. And that's how we're going to solve this particular problem. We're going to say that the definite integral from 1 to 4 of the absolute value of, and instead of writing that equation again, I'll just write it like that, is equal to the definite integral from 1 to 3 is where it has that sharp turn of negative v of t dt plus the definite integral from, 3 to positive 4 of the original function dt. Okay, and then if I'm going to solve this thing by hand, I would probably take this negative thing out, and then I have the same function to take the antiderivative of. Let's go ahead and do that. Right? Okay, so I have negative of antiderivative of our function. Our function was, what, t squared minus t minus 6 is going to be a t cubed minus t squared over 2 minus 6t. Evaluate that one from 1 to 3 plus definite integral from, oh, I haven't done it yet. Let's find the same exact antiderivative, t cubed minus t squared over 2 minus 6t. This one from 3 to 4. You can see that problems like this are rather tedious, right? Because you have to evaluate the same exact antiderivative over 2 different intervals. So we're going to just safe stop this one, if you don't mind. All right, so I have negative of, and I'm plugging in the 3 first, so that's a 27, 3 cubed, minus 9 halves, minus an 18. And then I have to subtract out the quantity with 1's plugged in, so 1 minus a half minus a 6. Right, and then add in the other part. Oh my goodness, let's see. A 4 cubed, what was that, 64, I think? 64 minus a 16 halves. Okay, I can just write that as an 8 minus 24, and then minus this whole entire quantity with 3 stuck in here. So, hey, I've already done that. It's this business here, which is 27 minus 9 halves minus 18. Safe stop. Now, according to my calculations, if you were to, and I would encourage you to do this because you probably have a spare minute and you're totally bored, throw that into the calculator and you should get something along the lines of 61 over 6. There you go. Well, what did we just find? We found the total distance traveled. If we had kept this part positive, then all of this negative area would have canceled out with some of this positive area. And it looks like there's more here. If I drew this to scale, which I didn't really, looks like that there's going to be more in the negative direction than there would have been in the positive direction. But taking the absolute value takes that negative part, flips it up here, and then we would add these two areas together to get that total distance.